Hi everyone, and welcome to today's webinar. Just a couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right-hand side of your screen. We'll go over all the questions at the end of the webinar. And of course, there will also be a recording of this webcast available within a couple of days. Now it's my pleasure to introduce today's speaker, Yishai Yovel, VP of Marketing at Cato Networks. Yishai has over 25 years of experience in defining and deploying enterprise IT software solutions in the areas of security, storage, business continuity, and mobile computing. Yishai, please get us started.
Hello everyone, and welcome to our webinar, sd-wan use cases and success stories. Before I start, I want to talk a little bit about the problem that we're trying to solve with today's wide area networks. In a nutshell, the WAN is incompatible with the way we do business today. We used to have simple networks where a bunch of branches had to connect to a data center over a very straightforward MPLS network. And then we had a firewall that allowed end users to connect via VPN to the data center. And this was basically our design for the past, couple of decades. And what is happening today is that the traffic flows in the enterprise have completely changed. We now have a very large portion of the overall traffic not having to go to the data center, but in fact reach cloud destinations. And we also have to do it at a global scale. So organizations are much more globalized today versus what they used to be in the past. And this change in the architecture of the business, which means that it's more mobile and cloud focused, made the existing architecture, the existing equipment, the routers, the MPLS backbones, even our security appliances are just not designed for this change in the enterprise network requirements. So how does that kind of play in our world? This is an example of an enterprise that has a headquarter, branches, mobile users, and cloud resources. And we kind of, as I mentioned, at the core, we had some kind of an MPLS network, which was managed by a carrier. And we lived in a world where the capacity of that network was limited. And at the same time, it had to carry a lot of traffic, both aimed at the data center as well as the internet, which was actually not something that actually needed to get to the data center, but architecturally, this is how we did it. And then we had a bunch of other sites were connected through site-to-site VPNs with firewalls. And because we had to put a firewall in each branch that was not part of our MPLS network, very often globally, then what we had is an appliance sprawl on one hand, so multiple devices to manage, and unmanaged connectivity, so no longer MPLS, but tunnels running over the public internet with all of its latency and packet loss and jitter, which made performance very unpredictable. Then we had to connect the cloud. This was a process that we've been going through over the past decade, where we moved workloads to Amazon AWS, Microsoft Azure. We're moving to Office 365, Salesforce. So again, a lot of the traffic had to go to the cloud. And now we had both locations, physical locations, using the open internet to get to those resources, or mobile users kind of traveling all over the place, where also they no longer had the access to the managed connectivity, the predictable connectivity that we had with MPLS. And on top of that, there was actually no security to protect that access, because those users would simply take their devices and directly go to the cloud resource and bypass all of the security that we had in the enterprise. So this is kind of what mobility and cloud had done to our network. Basically, MPLS, instead of being the heart of the organizational network became kind of almost an afterthought. So we turned into SD-WAN, and SD-WAN was basically focused on solving the issue of capacity and cost associated with the legacy MPLS network. So we got SD-WAN to add an internet transport to our MPLS transport and then manage those two transports together. The thing is that because the internet is the internet and we cannot get predictable and consistent connectivity, we had to keep the MPLS. So kind of there was no real way to replace MPLS, just to augment it. So overall, we may have reduced the cost per megabit, but fundamentally our current network design had to remain in place. Some of the other requirements were simply not touched. So our appliance sprawl, the firewalls, the side-to-side VPNs, they're still all there. Now that we're using internet in branches that previously backhauled over MPLS, means that we need a firewall solution to secure that internet connection in the branch, or we have to deploy some kind of a cloud-based security solution, and that means that we have more point solutions and more complexity as the price to pay to get more capacity and at a lower cost in the branches. And then mobile users and cloud access, nothing has changed there. The SD-WAN edge devices don't do much to optimize cloud connectivity unless you complicate the infrastructure even further with solutions like CASB, with deploying virtual WAN appliances in cloud instances, or in some cases, when this is not even possible, you have to open up whole new hubs just to optimize cloud connectivity. So basically, SD-WAN, which was focused on solving the branch problem, isn't very helpful when we think about all these problems together. So the bottom line is that as we started with the need to transform the wide area network from this MPLS backhaul-centric architecture to something that is more open and more supportive of cloud, internet, and mobility, SD-WAN is just too limited. If we think about the WAN edge component of SD-WAN, this is covering that requirement very well. We can augment our MPLS, we can do a hybrid WAN, we can manage two links together. This is all very valuable. But the SD-WAN doesn't actually touch on the requirements that we have in that WAN transformation journey. The security, the full security that has to be applied to all the internet access. The need to optimize connectivity with a global backbone between global locations. The need to seamlessly support optimized access to the cloud, not just mere connectivity to the cloud. And finally, mobile users that are totally out of scope. It's not something that SD-WAN today includes in any shape or form. So what we're seeing here is a broader set of requirements that has to be addressed in order to completely successfully address the full WAN transformation needed by most businesses. Bonnie, take us through our first poll question.
No problem. What are your biggest WAN challenges? You can mark all that apply. Global connectivity, change management, branch security, resources, or costs. You can answer now. Okay, we'll give it just a couple more seconds here. All right, thanks everybody. Ishai, you can continue.
So before I go and explain how our customers solve some of these challenges, I want to talk a little bit about about Cato Networks. Cato Networks was founded by Shlomo Kramer and Gur Schatz. Shlomo is the co-founder of Checkpoint Software and also of Imperva. Both of these companies are large public security companies that have been very successful, and Shlomo brings the network security DNA to our company. Gur Schatz, our CTO, has co-founded Incapsula, an anti-DDoS service. Gur is an expert in cloud networking and kind of brings the networking dimension to our business. And together, as you will see later, both of these capabilities are necessary to deliver the Cato network solution. Shlomo and Gur were able to raise, together with the management team, $70 million from leading venture capital firms. And I think the most important thing is that they are known to build architectures and companies that last, that all of these technologies and solutions they've built to date are category leaders in their respective markets. What we were able to build in Cato is a massive global network that spans now 39 POPs and deliver on a vision of networking and security in the cloud at a global scale. This network is built over multiple tier 1 providers, provides 24/7 network operations, and it optimized and secure everywhere we deliver our service. And in fact, we have hundreds of customers with thousands of global locations that are using our cloud network in production. And I'm going to talk about these case studies that I mentioned on the slide during the rest of the presentation. So what are the drivers for WAN transformation? What is it that customers want to accomplish when they come and talk to Cato? The most common needs are reducing latency for global locations and reducing the cost of MPLS through an affordable MPLS alternative. The way the Cato architecture addresses that need is through a global network of points of presence that run our networking and security software. We have 39 POPs, as I mentioned. They are interconnected by multiple tier 1 carriers, which are SLA backed. This allows us to provide SLAs at a global scale, which is something that the public internet does not provide. And we do it at an affordable cost. So at the core of the Cato solution is a cloud network that provides both predictable and consistent latency at an affordable cost. In order to ensure end-to-end optimization, we also offer a last mile management through the Cato Socket sd-wan device. We can either augment the customer MPLS network in case they want to keep MPLS and start with adding internet capacity, like a traditional SD-WAN, or we can fully replace MPLS, and many of our customers do that because we provide both a way to manage the last mile and to manage the middle mile. So basically you can get a consistent latency end-to-end, which is a requirement for MPLS replacement. The global backbone has the software which has the smarts to do optimized global routing, apply different methods to maximize reliability of the connection, such as choosing the right provider that has the best network characteristics in real time on a per packet basis, applying different optimization techniques like a TCP proxy to maximize bandwidth globally, and of course applying full encryption to all traffic traversing Cato's backbone. The next use case is appliance elimination. And this is where the security layer of our solution comes into play. We have built into the network a full network security stack that includes a next generation firewall, a secure web gateway with URL filtering, advanced threat protection with anti-malware and IPS as a service, CASB capabilities that gives you the ability to discover cloud access and apply security policies to access on an application level, and finally full analytics to all the security and network events that occur in the network communicated to your SIM or accessed through the Cato management application. This security stack enables customers to eliminate firewalls, edge firewalls completely. So all the traffic will come from the branch location to Cato, and all the security processing will be done in the cloud. No more UTMs, no more branch firewalls. This means that you can either eliminate those appliances and reduce the cost and complexity of managing them, or avoid the deployment of those appliances as part of your WAN transformation. In many cases, customers do not have branch firewalls because they're backhauling over MPLS all the traffic from the branch to a data center. Now with SD-WAN, they have to deploy some kind of a security solution. In our case, it's baked in, no need to do any sort of an added security service, either at the branch as an appliance or as a third-party service in the cloud. It's all baked into the platform. Next, we are integrating the cloud data centers. Basically, without installing anything in the cloud, and I'll talk about that, we can connect in 10 minutes every cloud data center that you have. Amazon AWS, Microsoft Azure, Google Cloud, and others. We can connect and make them an integral part of the WAN, subject to corporate policy, access control, full visibility. Essentially, the cloud becomes an inherent part of the network. Now, note that this is part of the design of the architecture itself. It's not a bolt-on, it's not an add-on. This system is designed to treat branches and cloud data centers equally. Finally, we can extend the WAN transformation to include mobile users. This is a really big deal because the mobile user inherently was out of scope for the wide area network. So what we're seeing here is that we can connect a user through a Cato client to the cloud network and then apply all of our optimizations, all of our security against mobile traffic, either going to the data center, east-west, or going northbound to the internet. Everything is handled in the same way. Okay, so these are the 5 drivers, and this is the architecture that holistically addresses all of these together. And now I'm going to talk about each one of them, what customers are trying to solve, and what kind of success they've seen deploying Cato to address those use cases. The first one, reducing latency for global locations. So what's the problem? The problem is when I have a branch in Asia connected to headquarters, in this case in the North America, over the internet, there's simply no way to predict the route the traffic will take, how many carriers are involved in serving the traffic, and the resulting packet loss and jitter. So this is a big problem. In some cases, the reason customers use this transport is because they can't afford to pay for global MPLS connection. This is very expensive. So what we did here is we are using our SLA-backed backbone to connect the 2 locations. So the branch connects over a short last mile to our POP in Singapore, typically less than 25 milliseconds away from the branch. Then the traffic runs over our optimized backbone using carriers like GTT, Telia, Sonera, and NTT, all the way to Ashburn, Virginia, where the traffic exits the backbone and goes over the short last mile to the headquarters in New York. So this is basically a way to achieve managed connectivity over the Cato backbone without deploying MPLS. And here's an example of a case study. Paysafe is a global financial firm. They have 19 locations essentially across all regions of the world, a mix of MPLS and VPN, and multiple firewall brands. This is kind of the existing situation. And they were facing challenges with latency between India and their data center in Canada, as well as access to Office 365 in the US. And also a complex security environment that basically kind of the mixing of MPLS and VPN created complex failover scenarios, as well as the ability to secure users that were moving between locations. And essentially what we did here is we standardized the network. So instead of a blend of different transports, now everything connects to Cato over the internet. The Cato Global Backbone optimizes access between India and Canada, as well as between India and Office 365. And basically, we are streamlined the network and the security architecture, okay, in a single platform. The next use case is affordable MPLS alternative. So this is really about cost reduction. And it's important to understand that the cost reduction comes in part by the ability to move from an MPLS last mile to an internet last mile, and then connect those last miles with the Cato managed backbone, SLA backbone. So in the case of Fisher and Company, this is an automotive company, roughly 7 or 8 sites. One of them is in China. They were using an MPLS network to connect all of their sites at the cost of roughly $324,000. And what they did is they shifted the last mile architecture from MPLS to internet, a high quality internet for the most part, symmetrical fiber, and then used Cato to connect all the different locations and China into a single network. And basically, this has driven down the total cost of the network by roughly 70%, but maintained the consistency and the predictability they got from their MPLS network. And this is a very important component. If you have a global network, sd-wan edge devices can optimize the use of the last mile, but they cannot guarantee end-to-end latency, packet loss, and jitter, which means that if you want to connect global location, you need a global backbone, which really increases the cost if you don't have that global backbone as an integral part of your architecture. And this is what you're seeing here. The next example is Alekhwinze. It's a Dutch engineering firm. And in this case, what they wanted to achieve is to eliminate the MPLS between Romania and the Netherlands, which they use to run video conferencing and Citrix VDI between the sites. And they also wanted to make sure that they don't have to deploy firewalls in those MPLS locations as they move to a new architecture, which is based on internet last mile. And finally, they had sites in Asia which needed to connect. Currently, they were connecting over VPN tunnels, not over MPLS, and performance was poor. And again, what we did here is we connected all of these locations over internet last mile and the Cato SLA backbone with full security and applied the same architecture everywhere. So again, the benefit here is that you can replace your MPLS with internet-based last mile and an SLA-backed backbone. This drives down the cost of the network dramatically, and at the same time, you get enterprise-grade security delivered everywhere, both in this case in Europe and in Asia. And basically, that standardizes, streamlines, and consolidates both networking and security into a single platform. Moving on, branch appliance elimination. So we talked briefly about our security platform, and if I really focus beyond the functional aspects of it, which I described, it's really the fact that this platform makes enterprise-grade security available everywhere. So you don't have to buy kind of high-quality security for your data center and maybe lower quality security for your branches. It doesn't mean that some locations have one level of security, the other ones don't. You also don't have to size those solutions. So the issue of how much traffic does the device have to process, what kind of traffic mix, is it including SSL decryption or not? And of course, you don't have to patch those appliances, upgrade them, or refresh them. This is kind of the core benefit of having a full security stack built into the network. What's really key about this is that the security stack does not just process internet-bound traffic, which is very common in security as a service solution, but also is applied to all traffic growing across the wide area network. So we process both wide area network and internet-bound traffic, which means we can fully replace firewalls, edge firewalls, which are often responsible for both types of traffic. And here's how it looks. So on the WAN side, the architecture of Cato can create an instant full mesh across all sites. You don't have to define tunnels at every edge location to all other edge locations. If you are in the firewall management business, you know what I'm talking about. You have to build IPsec tunnels, maintain them, and then basically coordinate all the different failover strategies, routing across this full mesh. It's very, very complicated and very time consuming. Here, all the edges connect to the Cato Cloud Network, and you can get an instant full mesh and then constrain the full mesh, either allow or disallow different edges to talk to other edges simply by using rules. You don't have to establish physical connectivity between the edges or logical connectivity with tunnels just to get them to talk to one another. So a very easy way to establish the mesh. And then the same interface, you can define your internet policies, which in a way that is application aware. This is a next generation firewall, so you can define which locations can access which applications. You can see here how we constrain access to LinkedIn and Facebook from different locations, as well as defining exceptions. You can see them in the bottom for specific users that do need this access to do their job, for example, recruiters. Okay, so again, one interface to cover both wide area network mesh as well as policies to control internet access. So Pet Lover Center, a retailer in Asia, has used this architecture to protect their stores. They have 65 locations in Singapore, an additional 40 franchisees in the rest of Asia Pacific, and they wanted to apply enterprise-grade security to all the stores everywhere. So initially, they rolled out the solution to 65 retail stores in Singapore. This is what we would typically call firewall as a service. There's no real connectivity play here because everything connects to the same POP. But then they extended this deployment to the rest of the region, and now we're talking about an international firewall as a service with the benefit of an MPLS alternative. So essentially, now all these locations are subject to the same security policy. They're benefiting from the SLA-backed backbone, and the customer did not have to shift architectures or deploy a different solution just to extend the footprint from a national to an international footprint. Next use case is cloud data center integration. And here, we've spoken about this earlier. So Cato can connect the cloud data center in a 10-minute configuration. There is nothing to install in the cloud. But what's even more important is that we are optimizing cloud routes. So when you have to access the cloud from a branch or from a mobile user, our cloud network take your traffic as close as possible to the cloud provider, because our infrastructure, our POPs, are co-located with the major cloud providers like AWS and Azure. So you don't have to use direct connect or express route from the different branches or data centers, because we will take your traffic from the edge, from your edge, and bring it all the way to the cloud edge for the cloud provider. This is a major benefit. And here's how customers took advantage of it. So this UK-based corporation wanted to connect 3 branch locations to Azure using their Sophos firewalls. And they were simply not able to do it within the time frame that they've allocated to it. So they brought us in, and we connected that scenario in 1 day. Why? Because we break it into 2 simple steps. The first step is to connect 3 branches, and the next step is to connect Azure. And we know how to do each one of these steps very quickly. The Cato Cloud creates the interconnect, the glue that puts these two pieces together. The customers saw that this was working very, very well for them, and they've, over the next 60 days, they've moved the entire network to Cato. So you can see here AWS in the US. So now this is a multi-cloud environment. We see multiple locations in Norway, in Switzerland, in India. So this is now a global network. And all of this is done in the same environment, the same interface, the same architecture with a single platform. Okay, so you can see here the diversity and the reach that the Cato architecture can achieve to address this use case. So very often our customers will start with a specific use case they want to solve, and then they end up with addressing additional requirements, additional use cases, additional needs. Another example, Spotted, technology company. They have 9 AWS data centers in the US, in China, in Germany. Essentially what they did is they wanted to provide mobile users, which is essentially their developers, access to the different cloud instances. Instead of logging in and logging out from every cloud instance separately, now it was possible using a VPN, using the Cato VPN client to connect to the Cato network, and then based on permission, access any IP range, any system within any cloud without having to think about where that system actually is. So we basically made a flat network that is fully controlled, fully segmented using the Cato cloud. So that's Spotted. Going on to the last use case, optimized mobile access. And here, what we basically did with the architecture is extend all the WAN optimization benefits, the SLA-backed backbone, the TCP proxy, the kind of this, all this basically redundancy and resiliency. All of this is now extended all the way down to a single mobile device. The Cato client finds the nearest available POP, and then the traffic runs on the backbone either to the cloud instance, the cloud application, or the data center, and where we manage the traffic routing end to end. This is the benefit of using an architecture that was designed to accommodate, as I mentioned earlier, all these different edges, physical locations, data center, cloud infrastructure, mobile users, using a single kind of very well thought out architecture, and not thinking about these different elements as bolt-ons or as an afterthought. And here's a good example. Edroll, again, another global tech firm. They have offices all over the world, users working from home as well. And all of these people had to access a single firewall in the headquarters in San Francisco, and that created a choke point that slowed down performance, not to mention the fact that we're using internet to reach San Francisco, essentially globally, which created a very unpredictable user experience for these users. And what we did here is we connected this entire, all of these resources into the Cato cloud. So we connected the San Francisco headquarters, all the branch locations, all the different cloud data centers that they have, and we deployed the Cato clients for over 700 users. So now the choke point is eliminated. Every user can get to every cloud instance they need to go to directly through the Cato optimized network. Security is applied to who can access which instance. There's full visibility into who is accessing what system. And there's full protection, full security protection for all this access globally. Okay, so this is a very good example when you take an organization that is really cloud-centric and mobile-centric, and you remove all this physical kind of shackles that holds down the architecture from operating, you know, in the way it was supposed to operate. And the way we addressed it is by putting a cloud network in the middle to connect all of these resources, which is a very natural extension of how this organization operates versus using physical edge devices that are bound to specific locations. I want to talk about one more use case, which is simplifying network automation. This seems like an underlying driver, not a driver by itself, but many customers do want to get more agility, speed, kind of getting stuff done quickly. And this is something that they don't get from their existing wide area networks. So I want to take an example here with Sunrich. It's a food processing company based in Canada with offices in the US. Seems like a small environment, only 5 sites, but amazingly, they had 2 different MPLS providers in the 2 countries. They used sd-wan appliances to offload MPLS in order to reduce cost, and they also had to deploy a firewall to manage that internet connection or secure it. They had WAN optimization appliances trying to maximize the MPLS links that they have. So you see many moving parts for a relatively small architecture, managed, of course, by a relatively small IT staff. So the question was for them is, how do we streamline all of these moving parts in order to reduce cost and complexity? In other words, how we make the network simple. And what they basically did is connect all the different locations and resources to the Cato Cloud, eliminate MPLS, eliminate the SD-WAN edge providers they were using, eliminate the firewalls, eliminate the WAN optimization devices, and now they're using one system, one product, one service with one management interface that a single person can manage. This is essentially why customers look at us. It doesn't matter if you're small, middle, medium size, or large. Everybody looking for a way to simplify their network operations and move at the speed of the business. And this is what we achieved here in Sunrich and essentially in all of the deployments that I covered. I want to finish with a summary slide that essentially talks about convergence. The main message that Cato, the main value that Cato brings to the market is that we have built an architecture that converges multiple dimensions of the wide area network. Last mile optimization, middle mile optimization with the SLA backbone, security, cloud integration, mobile access. This is stuff that everybody needs. You may not need it today, you'll need it tomorrow because you want to ultimately extend the benefits of your WAN transformation to everything the business does. The network is everywhere, the transformation has to be applied everywhere. And what Cato does is we allow you to do what we call 6-in-1. First, we provide a global MPLS alternative that is affordable and also a solution to manage the last mile like an edge SD-WAN device with our Cato socket. Next, we provide built-in security, which replaces any firewall as a service, security as a service solution you may be considering, as well as your edge firewall devices, the UTMs that you may have in the branches. Next, we integrate, secure, and control your cloud data centers and your cloud applications. So if you're considering a CASB, you're basically getting CASB capabilities built into the Cato platform. And finally, we extend our solution to mobile users, which means you don't need to use remote access solutions, VPNs. They all go away and they're replaced with a better platform that improves user experience, improves visibility, improves security. Basically, all of this is available now to the mobile users in your business as well. This is the 6-in-1. So wherever your use case is, whatever your starting point is, it is almost guaranteed, just based on our customer life cycle, that you will want more. And instead of limiting yourself to a point solution that tackles a specific aspect of your WAN, it may make sense to look at something that allows you to start small or start with a specific pain or concern that you currently have, and then seamlessly, easily evolve to address a much larger set of requirements and ultimately maximizing your return on investment. this is it for me today, and I'm handing it over to Bonnie to take us through a couple of poll questions, and then we'll open up the Q&A. Thank you for listening.
Thank you, Ishai, for a great presentation. Let's start with our next poll question. Would you like a free pilot that can get you on board with sd-wan within 24 hours? You can answer now. All right, we'll give it a couple more seconds here. Okay. And our final poll question, would you be interested in a free estimate of your networking and security cost reduction using Cato? You can answer now. And while you guys are answering, I can see we have a lot of great questions, so let's get started with those. First question, what kind of redundancy do you have in the cloud network?
Thanks, Bonnie. Our cloud network has multiple layers of redundancy. Each endpoint we support dynamically tunnels into any machine at the closest POP. Each POP is composed of multiple machines running our software. In case of a machine failures, tunnels are instantly reestablished into an alternate machine. If a POP fails, the tunnels will connect to a machine at the nearest available POP. The key design element here is that unlike typical networks, there is no one-to-one bind between a customer location and a specific POP. This creates tremendous level of automated resiliency within the network.
Okay, next question. How are you different from Ariaka and VeloCloud?
VeloCloud is an edge-based SD-WAN and does not provide the cloud network. As a result, customers still need to depend on expensive MPLS for their global connectivity needs. In addition, VeloCloud doesn't provide a security stack, so customers need to procure cloud-based security services or deploy appliances for secure direct internet access. Lastly, VeloCloud doesn't provide support for mobile users, which are an essential part of the WAN. As about Ariaka, in regards to Ariaka does provide a solid but very expensive global network. Network security isn't part of the offering, so customers need to address that part separately. And Ariaka's mobile solution optimizes traditional VPN access to the data center, but not to the cloud, unless customer backhauls all traffic to the data center, something that is very bad for performance.
Okay, great. Next question. What do you provide for last mile aggregation if I migrate off MPLS?
Cato works with the global internet service aggregators that offer a single contract and a single invoice for all last mile services needed by the customer. This addresses the complexity of signing up individual internet service providers at every location as part of the MPLS migration. So overall, this is an answer to kind of the single throat to choke that customer had with MPLS.
Okay, great. And it looks like we have just enough time for one last question. And this question is, my local provider offers a bundle of last mile, global network, and hosted firewalls. Why should I take you?
So as we discussed throughout this presentation, legacy service providers are integrating all the different pieces with kind of a duct tape. All the underlying complexity and third-party products makes them slow and cumbersome. Cato is a new kind of service provider. We're faster, nimbler, and control the software that makes up our service. With us, the service is more affordable, it evolves faster, and you have one self-service interface to run your security and networking. We call it the Un-carrier experience. You're welcome to give us a shot and see how simple it is to do business with Cato.
Okay, great. I'd like to thank everyone again for joining us today. And of course, thank you, Ishai. You will all receive an email with a link to view this webinar again within a couple of days. And we look forward to meeting you again at our next webinar. Thanks, everyone.